Hello, and thank you for joining our webinar. While we wait for the people that are still joining, on the screen you can see a link where you can sign up if you want to receive invitations to other webinars, to other meetups, hands-on labs, and in general, learning resources in the world of big data and open source. So just go to this link, ibm.biz/datagurus, and sign up, and we'll make sure you are invited to future events like this. So today we have on the agenda to talk about the easy deployment of open source databases on the cloud. And we have our speaker, Saswata, who's going to be presenting. He's going to be discussing the topic for a few minutes, and then he's going to do a demonstration of the technology. I would also like to invite you to download a handout that can be downloaded from your GoToWebinar control panel. And this handout also has information about a couple of webinars that we have on the schedule for the next few weeks. So with that, I would like to invite Saswata to get started with the presentation. Thank you for joining us.
Thank you, Anna. Can everyone hear me?
Yeah, everyone is on mute. Everyone's on mute now, but no one is letting us know that they're having issues with the sound.
Okay. Hello, everyone. Thanks for joining today's webinar. My name is Saswata Sengupta. I'm an open source technical evangelist. I work for IBM about 2.5 months, 3 months now. I've been working with open source technologies, and one of the technologies which is IBM is bringing into the market, which is very exciting for me, and I hope it is exciting for all of you who are joining, is IBM Compose. It's a single platform for enterprise databases, a managed cloud-based database offering, which comprises of 5-6 databases, and it's fully managed, fully provisioned, and any organization who is looking to have multiple business use case can use IBM Compose, use particular database, and then deploy their applications. So talking about the organizational database needs, in today's world, the reality is for every kind of business use case, you have specific databases. So for CRM and supply chain management, you have relational databases which needs to handle high volume of transaction, example Postgres, MySQL, Oracle, Sybase, DB2s of the world. Then you have this databases for the mobile and web application, which could have data in a JSON format, could expose REST APIs, it could act as a fast cache or document store. An example could be MongoDB, Redis, RethinkDB, ScalaDB, Cassandra, so on and so forth. And then there are other application databases which are like Elasticsearch and RabbitMQ, which could be used for search and messaging, and then etcd for configuration management. So in all, an organization, depending on their business need, their departmental needs, they would require multiple databases with specific features and functionalities to handle their business and their technological needs. Now, all of these databases would require a different database administrator who could actually look after the database, do the patching, monitoring, optimization, and so on and so forth. And it actually could become a big headache for an organization to have so many administrators monitoring the databases, infrastructure issues, so on and so forth. So IBM brings Compose to you. And what is Compose? Compose is a production-ready database which can be provisioned in the web in minutes. It can scale very easily, and you can pick and choose right databases for the right job, and Compose will manage the databases for you. So what are the databases which are available in Compose? You have MongoDB, you have Redis, Postgres, RethinkDB, RabbitMQ, Scala, DB, Elasticsearch, MySQL, etc. And the good thing about Compose is that it is a managed platform. It's available as part of IBM Bluemix, which runs on SoftLayer. It is available on your Amazon AWS. So if you have data sitting on Amazon AWS, you don't need to kind of move out of that. You can take full advantage of AWS, have Compose installed there. And it's also coming on the Google Cloud platform. So whether you are owning the organization departmental needs or you are a technological consultant who is looking to deploy a database on the cloud, and if you want to go Bluemix, you have the option of using Compose on Bluemix. You already have AWS-based infrastructure, which we understand a lot of people are using S3 for their storage. You can still use Compose, and if you're moving to Google Cloud platform, you can use Compose in Google Cloud as well. So it gives you that flexibility to kind of deploy in any cloud platform. Now, talking about some of those databases and their typical industry use cases. MongoDB, for example, is a NoSQL database which is reliable backend for a lot of mobile and web applications. It has been widely used. Redis, on the other hand, is used for caching and persistent store. Postgres has been there for many years. It supports transactional applications. It's a very good alternative for Oracle and MS SQL Server. Then you have RethinkDB, which is part of IBM and product suite. It's a very scalable JSON data store. Then you have RabbitMQ for messaging. It can act as a message broker collecting streams of data. You have ScalaDB, which is an alternative and becoming very popular alternative to Cassandra, which is a columnar data store, but it has a low latency of Redis. Then you have Elasticsearch, which is a full text searching engine with HTTP web interface and can store JSON documents. MySQL, very popular. Again, an open source relational database. etcd is a distributed key store mainly used for configuration management. So in all, this Compose suite kind of gives you a whole range of database which you can use for particular business use case, and you can pick and choose a combination of database to do your work. So you can use a RabbitMQ, for example, for a message broker, and you can take the data, cache it in Redis, and then you can put it in a more kind of a structural schema format into PostgreSQL or MySQL. So you have the whole stack which can do everything for you. Now, coming back to this slide, which talks about how Compose is available in two flavors. One is IBM managed, one is self-hosted. Now, IBM managed is very popular, which means IBM takes care of the patching, the monitoring, and services. Self-hosted is on the sometimes on the private or hybrid kind of cloud infrastructure where you want to kind of provision it by yourself. That option is also available. And backups are available at no cost, elastic scale out. Then you have the intuitive dashboards to look into the data. All services are production ready and high availability is available out of the box. Here's one example of how you can build a data layer. So in reality, when I was talking about an enterprise, how they are actually using the data, they are not using one database at a time. So for example, if you want to build a data layer, you can use a combination of ScalaDB and MongoDB for operational data ingestion, and as well as using for mobile transaction. A combination of both can be used, and a single licensing will suffice for you. You don't need to buy separate licenses for Scala or Mongo. Same thing with Postgres and MySQL, Elasticsearch, and then Redis and other databases. These are some of the deployment options for Compose. You have the SoftLayer AWS kind of a deployment option. You have the self-hosted option or the IBM managed option for you. And minimum 3-node high availability cluster is required. Backups are automated and available at no charge, and all the patching, everything is IBM managed, and This is actually going to take away a lot of headache which uh, a system admin would have, or a resource requirement an organization would have for a system admin who is actually doing those backups, automated patchings and all this stuff, and then monitoring the services and everything. So everything is being taken care by IBM. Now, when you are buying Compose, you have actually three options. These are like three t-shirt sizes. You have the starter pack, which is only available in AWS, which is a 3-node minimum 16 GB RAM. And the disk sizes are given. It's 160 GB or 240 GB for Postgres, then 160 GB for Rethink, etc., etc. The second one, which is the most popular and being used for a lot of transactional purposes, is the transactional cluster size, which is 3-node cluster, 64 GB RAM, and you get enough disk space, 640 GB disk space. Now, if you are scaling out and 640 GB is not enough disk space for you, what do? You get more nodes, and therefore you get more disk spaces. So disk spaces are directly proportional to the number of nodes. So minimum 3-node configuration is what you are looking at. This is very good to start a POC or a proof of technology for you. But then if you want to expand and implement a full business use case, you just expand the number of nodes and you get more storage. And the large transactional cluster, it's about 256 GB RAM. This is used for enterprises who are actually deploying larger applications. They are beyond a POC or a proof of technology stage, and they are actually doing some production implementation. This is the size which is available, and this is the disk space, which is 2.56 terabytes, almost for most of the databases is available. And obviously, if you need more, you need increase the number of nodes. Now, here is one good thing about Compose. You are not restricted to just getting one database. So if you have got a 3-node cluster and you have got 640 GB of storage, and your business use case needs multiple databases, or maybe you want to try out a different database for your business needs or technological needs, you can do that. So you can do a combination of a 640 GB, or you could break it down into 320 GB, 320 GB, or a different size altogether, and you can provision multiple kind of your databases and database services. And this has been our experience with our customer, that they start with a small database, but then there is a need for a different database. Instead of getting one more license, they can just split the license, and if they have enough storage bought, they can actually split it up and spin off another service. If customer who have been traditionally in the AWS space, Compose actually supports AWS, and these are some of the recommended size for the clusters. For starters, we are looking at a 4 CPU M4 large servers. For transactional, it's R3 2x large servers, and for large transactional, it's R3 8x large servers. 4 CPU versus 8 CPU versus 32 CPUs, and everything is virtual private servers. So if the customer or an organization wants to provision Compose on an AWS kind of an environment, this is a recommended kind of infrastructure. Now, a lot of customers who have their legacy application built it on-prem. Obviously, when you're moving to the cloud, there are a lot of moving parts to it. You have to move the data, you have to provision the service. Now, Compose do take care of your provision, takes care of your monitoring. Now, what about the data? You will have a data sitting on your premise. How do you take it to the cloud? So there is an open source tool available for the customer. It's called Transporter. It's a JavaScript based open source tool, very similar to those who are familiar with JDBC or DBC kind of a connector, or maybe if you are coming from a Hadoop world about Scoop. It's similar tool. It's available in GitHub, and it helps you do the bulk uploads as well as continuous synchronization of the data. One thing it doesn't do is incremental loads based on a particular key or particular timestamp, but it can do bulk uploads at one point in time, and also some of the continuous synchronization if the transaction is still happening. So in most cases, customers who are migrating to the cloud, they would do a bulk upload, then they will run the system parallelly, so the continuous synchronization can happen, and then at some point when they are comfortable, they will sunset the on-prem and then keep on using the cloud. And this is for any production kind of a system. When you are doing a proof of concept or you are trying to build something new, obviously you don't need this tool. You just upload the data and everything should be available for you. But in case if you want to do a parallel run, you can use a continuous synchronization feature. Backups. So backups are very important. IBM takes care of your backup, and the backup are snapshots which are taken daily, and rolled weekly snapshots, and there is a monthly snapshot, and these are all configurable. Backups are typically stored in S3. But right now, IBM also provides its backup in the software object storage. So you have the option of putting the backup either in S3 or an object store. Now, obviously, if you're deploying Bluemix based Compose, we recommend that you use software because of the lesser kind of a latency in moving the data around. But if you're using AWS kind of infrastructure, you have definitely the option of storing the backup in S3 kind of an environment. Right now, Compose has about 4,500 developer team. These are some of the organizations who are using Compose: Intel, eBay, Salesforce, Carnegie Mellon, Logitech, Domo, Nordstrom, McKinsey, etc. So there are a bunch of customers there, and this product is a mature product enough so that you can go and do a deployment. It's not something which is being tested out. It's in beta, so and you would be skeptic not to implement it. It has been implemented in multiple customer locations, and these are some good names. Having said that, I wanted to run a quick demo of Compose here, and this is a recorded demo. So once the demo is done, I will kind of go through the application once more and show the audience about the Compose environment.
There's no sound on the recording. Suswata, can you describe the demo?
I'm sorry, can you hear the recording right now?
No, we cannot hear it.
Okay, I'm sorry about that. So let me just run through the demo here. So this is a Compose environment. There is a Hello World example which is available on GitHub. So for this example, you need to have the Bluemix account and the Cloud Foundry tool available, the CLI available. I have already downloaded that. When you go to this GitHub, you will have a repository which you can clone, and this is the repository which I'm talking about. So this is where I would be cloning the uh, environment. Now I am going to change the manifest.yml file, and it will give me the host name. The memory size is 128 MB, which is by default, and I won't be changing this because this is going to be good enough for the application which I'm building. The service name has to be unique. If you have a duplicate service name, it will actually kind of create an error. And the host name I will be creating, and this is actually going to be appended to the mybluemix.net, and that's where I'm going to run my application. And I'm going to save the file now, and I'm going to come out of this console. The next step is basically to log in into my Cloud Foundry Bluemix. So I will be using the Cloud Foundry API to log in into my Bluemix. And then I log in into my Bluemix account. And for those who are looking at this demo, the Bluemix account is available for free, and there are multiple applications and databases which you can try out. So now I am in the Bluemix, my Bluemix account. Now what I have to do is I have to create a MongoDB Compose services in Cloud Foundry, and I'm going to use the standard plan, and the configurations would be taken from the manifest.yml file. So when you run this, it probably will tell you that the standard plan uh, is not free for compose for MongoDB, but as long as you don't increase the memories and you're using lesser kind of a resources, we should be fine. Now I would be binding and pushing the application. So everything is being uploaded successfully. The binding is completed. The application is starting, and if you see that it's creating a route for test mdb.mybluemix.net. The build is successful here. And the instance is running right now. So I have successfully built an application, started a Compose MongoDB services. And this is the URL where the application will be available. And this is a simple uh, put and get application which I built using Node.js and MongoDB services. So let's now log in into the Bluemix environment. So Bluemix account is free. When you log in, you don't even need to put the credit card. You can just create your account in Bluemix and play with a lot of services in the catalog. So once I log in into my Bluemix environment, under Cloud Foundry application, I can see my testmdb, my bluemix.net application available, which is a MongoDB Compose application. And I also see my MongoDB services available. You don't have to use Cloud Foundry. You can also create the service using Bluemix. So you can go to the catalog. You can choose the data and analytics. And under data and analytics, you will find a lot of Compose services which are available. And choose the appropriate database services which you want, and you can spin off a service. So when you click on this service, it actually will take you to a page where it will show you about the status. So right now it's being provisioned and the provisioning is in progress. You can check for the service credential and you can create a new service credential. You can click on the connection and this will actually take you to the connection dashboard. So this is my runtime environment which I have built with Node.js. There's one instance running and the cost is actually 0 because I haven't exceeded the memory utilization. And you can, if you are an advanced user, you can enable the continuous delivery. These are the ways to create the API keys and the credentials. You can click into log and look into all the logs. And you can also go into the monitoring and also add test cases if you want to. So this is an overview of your Mongo services. So going back to the dashboard, I can click on my testdb. This is a simple application which has been built. It's a simple put and get application, and the data is being stored into Mongo and the output is being shown instantaneously in the console. Now, when I go back to the service credential, I need to make sure it's ready. Sometimes it takes a little bit of time, probably about 2-3 minutes, because it's provisioned around data centers. But you don't need to restart or recreate the service. So you can just wait and you will see the status being ready. Once the status is ready, you can go back to the application itself and then start ingesting data and look at the output. So you can add the data here and you can actually start looking into the data. So I added the first sentence. Now let me just change and add a couple of more words. Hello 1 2 3, and then it's defined as greeting. I will add a couple of more words, and then it should be available to you instantaneously. And this is a very good way to check out the application if you're looking to do some proof of technology or proof of concept. This is the way you can build your applications quick and easy. You can use Cloud Foundry, and you can, in the dashboard, you can see the services and application available and running. And you can monitor your Mongo services coming up here. So if you're ingesting more data, if you want to look into the memory utilization, you can do that here as well. I hope you guys like it, and I definitely encourage everyone in this webinar to go ahead and try out the Compose services. There are very good examples there to create applications using Elasticsearch, Mongo, Redis, and all other applications. So you can definitely go ahead and try it out, see how it works. These are available for you to you for free, and you can start building some applications quick and easy using your Compose services in the Bluemix. And the principles of AWS would be absolutely same. You will be doing the using the Cloud Foundry. You can build a service, and then you can build an application on top of it. So some of the questions regarding the database health and monitoring and usage, uh, which a typical database administrator would look at. With AWS, we have the monitoring dashboard available, but with Bluemix, it's being provisioned. Actually, it's available right now as of Q4. So you will have a full-fledged dashboard where you can see the health of your database, kind of a storage it has been utilizing, the memory and all this stuff, which is different from the dashboards which we are looking at. Now, archiving policies are on a 3-month basis. Beyond 3 months, Compose would not archive the data, but the data would be available in S3 for you to pull it, bring back into your cluster and do some create another database table on top of it and look into the data. Now, self-hosted private cloud, there was a plan to roll it out in Q1 of 2017, but it's going to take a bit of more time. It probably is going to be on Q2 of 2017. So if you want to have a private hosted, not cloud, not public cloud kind of a Compose environment, it could be available on Q2 of 2017, but the public cloud is available, and it's going to be IBM managed. Some of the demo guides, I ran the MongoDB demo from GitHub, but there are some good demos which are available in the GitHub for IBM Bluemix. You can try out the Elasticsearch as well, which is similar to Mongo, and it will give you a very good flavor of how to use Compose as a service and how you can load and ingest data. And also there is an interesting article which I encourage everyone to look at. It's 7 databases in 7 weeks or so. So how a developer can provision and create 7 different databases. It's available in the developer.ibm.com website. That concludes my presentation. Over to you, Anna.
Are there any questions in the audience? You can either raise your hand and I will unmute your line, or you can just submit a question. One question I received was whether we were recording the webinar, and the answer is yes. You will receive an email within the next 24 hours with a link to the recorded presentation, and we will also make available the slides. So I guess there's no question. So just to close, I would like to invite you to download the handout. That's you can download from the GoToWebinar control panel. And that has information about a couple of webinars that we have scheduled within the next few weeks. And it also has the link where you can sign in to ensure that we're sending you communications and inviting you to future webinars, meetups, hands-on lab sessions, and other learning resources. So thank you very much for joining us today. And thank you for your presentation, Suswata. And I guess with that, we'll close the webinar.